Welcome back to the presentation on classical geometric construction of whole number anchors in general. My name is Kume Alex, and in this video I'm going to teach or to show how to construct an anchor of 8 degrees. In the previous presentation, I have shown how to construct an anchor of 1 degree and 2 degrees. In this video, we are going to learn how to construct anchors of 8 degrees. This is it, again depending on these two papers. As it has been shown in these two papers, short review on classical construction of number anchors and the anchor trisection problem, which is a review of some constructions, including the possibility of the anchor trisection. So to construct the 8 degrees anchor into the 9 degrees, we will greatly depend on the 32 degrees anchor. If we are able to construct 32, we must be able to construct 8, and we must be able to construct 9. So the initial bit will be construction of 32, then you can do some other operations such as bisection 32 give us 16, from 16 we go to 8, and from there I'll show then how to produce 9 degrees. So straight away I'll go to the GeoGebra software and we begin the operation. As usual, I have to prepare the necessary tools for this construction. I already have the line and need the bisector tool. Importantly, I must have this compass tool. Now that's in place, and I'll have to move the figure or the Cartesian plane inside a bit that way. To begin with, I'd like to have some straight point or in a straight line between 2 points. And I'll follow it 2 points, let it be there, and maybe here. Yes, so nice points. And then pick the straight line from here and connect between the 2 points AB. Now this is usually the baseline in any form of a classical geometric construction. I'm going to employ use of this compass to help me create a point C that should be equidistant between the 2 points AB, and the goal here is to generate the two chords we have seen in the previous video of construction of 1 degree. That's the chord DG and DF. I want to generate the two chords here again by drawing two arcs equidistant from these points B. You know that I must use either of these 2 points or both of the 2 points as centers. And using the leveling tool here, I get my point C that way. Next, I'm required to join the point B to C using a straight line, and I pick the straight line from here, join point B to point C. Next, I will bisect this line, and I'll use the anchor bisector tool simply because I'm going to use it in most of the constructions. I have the bisection. Now I use the leveling tool to help me label the points D from this point and point E that way. I will again go further to bisect anchor EDB as we have seen in the previous construction. So here I'm going to go first, and I'm going to show a very simple construction of 8 degrees. There I have the bisection. I'll use this tool to label the point of intersection between the bisection through D and the curve BE as point F. I'll again come here and pick a tool here for magnification. I will zoom in the figure that way, and then again come to pick my anchor bisector tool here to help me accurately bisect angle EDF as such. Now after I have the bisection through point D, I come and pick the labeling tool here to label this point of intersection as point G. Now we have the necessary tools for construction. I'll slightly move this figure inside that way. So next, for me to construct 8, as I've said, I must have that too. And I'm going to have the point center, point E as my center, simply because anchor EAB is 30 degrees. To justify that, I'm going to use this straight line here to join point A to point C. Bearing in mind that point C is equidistant between the 2 points, it shows just been constructed using an equal radius, and therefore the line AC and BC are equal to the line AB. So that's the lines BCCA is equal to AB, and that's an equilateral triangle. So bisection of this angle, which is 60, should be 30. Now I'll use the point E as my center, and using the compass tool, I carry that and this. I start from point E. Now I change the appearance of that as usual into another color. Let me pick that for some good clarity. And again, using the labeling tool, I label here as point H. I'll come again and pick the compass tool, which would help me carry this distance DG accurately, and using point H as my center, that way I have my point here I. Before I get I need to change the appearance of the curve into blue. I will slightly zoom in for accurate labeling of this stuff, this figure here. I'll pick the point A and put it from that, pick a point from that tool and put it there, and that's my point E, not really point A. Now I slightly zoom out that I can have a good look of what is inside. I'll use the angle bisection tool or the bisector tool again to bisect angle I, A, B. Sorry, I used the escape key to delete that. It shows I did not have to get on the points clearly. Something is wrong. I need to have my point A in appearance. Right. I'll come to pick that, and starting from C, sorry, I have to start with I, not C this time round. Such mistakes are common in geometry, and you need to be very careful. You have to be very careful. And I have the bisection here. I'll make it that type of green. I'll use the labeling tool to help me label here as point J. I'll go further and bisect angle J, A, B, that way. And here I'll change this one into a different color. I can give it that color blue, that type of blue. And again, using the labeling tool here, I label this as point K. We can measure the size of the angle K, AB, K, A, B, and that's 8 degrees. Now, that means angle I, A, B is 32 degrees, and angle J, A, B is 16. We are done with that step of construction. Next is to generate an angle of magnitude 9 degrees. We can get 9 by bisecting an angle of size 18 degrees, and we can construct 18. So in the next video, I'm going to show how to construct an angle of 9 degrees in a separate construction. Thank you for viewing. Please remember to subscribe for this presentation.